Hello and welcome. My name is Neelay Thaker. I'm Director of Product Marketing at Microsoft. With me co-presenting today are Ravi Sudhakar Kambhampati, who's the Director of AI/ML Strategy at Microsoft, and Anand Kulkarni, who's the CEO at 𝗦𝗽𝗲𝗸𝗀𝗀𝗀. In this session, we'll talk about how startups and cloud-native companies like yours are disrupting their industries and growing rapidly through the use of AI. So let's dive in. It's just been a few years since OpenAI first released its GPT models. And just in these few years, the growth of AI-based innovation has been exponential. If 2023 was the year of experimentation, 2024 has been the year of production. And many of our companies, startups, as well as at-scale born in the cloud companies have moved their apps to production. Startups that are building with AI are much more likely to get funded and are much more likely to succeed overall. And all of these startups are disrupting their industries through the use of AI, and particularly generative AI. We see three kinds of startups in general for AI-based innovation. First, there are startups that are building solutions for the Gen AI toolchain, helping other developers more efficiently build AI apps. Second, we have AI-based startups that are building horizontal solutions. These are solutions that are applicable across industries. And an example of such solution is customer service chatbots. Then we have startups that are building solutions that are specific to verticals such as healthcare, financial services, retail, and other professional services. And the sheer number of AI-based startups is expanding rapidly, with 2 times more startups that are AI-based in 2023 compared to the previous year, 2022. And AI is rapidly changing the priorities for startups and cloud-first companies and having an even bigger impact on the priorities that already existed for them. First, there's the need to accelerate innovation. And cloud-first companies, especially when they are building AI-based innovation, the need for acceleration is even more. Second, they need to adapt rapidly to changing market needs. With so much new innovation coming out in the AI space on a daily basis, startups have to adjust their strategies and what they are building rapidly to keep up with the times. And in order to succeed, they need to pivot multiple times. Third, once they get to an MVP, they need to scale rapidly to capture that early majority of the customer segment. And finally, they need to build solutions and take them to market as quickly as possible, at creating a seamless experience for their developers from proof of concept all the way to production and beyond. Microsoft really helps companies, both startups as well as at-scale born in the cloud companies, address these priorities. First, Azure has a comprehensive portfolio of industry-leading AI services that offer a wide range of models, frameworks, services, as well as tools that help you create highly performant as well as cost-effective AI apps. Second, Azure also provides the application platform and infrastructure services that help you scale your AI apps quickly. Third, Azure offers a choice of scalable and cost-effective database services, both based on open source technologies as well as proprietary databases for you to choose from. And finally, Microsoft provides the end-to-end comprehensive portfolio that includes a wide range of comprehensive DevOps and DevSecOps services, including GitHub as well. In fact, in the first Magic Quadrant for AI-assisted code development, GitHub Copilot was named a leader in the quadrant. So why use Azure for AI? There's many really good reasons for you to use Azure to build your next generative AI app. The first one is building AI apps with speed and agility. And this, as I touched upon previously, Azure really offers a choice of an extensive model catalog that you can choose for, which is the best match for your Gen AI application, as well as best in class services where you can use out of the box capabilities like text to speech and document analysis. Second, you can use Azure's AI services to deploy mission critical AI solutions. These are the same solutions that industry leading Gen AI based applications such as ChatGPT are deployed on. Third, the Azure cloud is the most trusted and compliant cloud platform available today with more than 100 compliance offerings. So, especially if you are building solutions in highly regulated industries such as financial services or healthcare, Azure really provides you with that solid foundation of compliance that will help you meet your customers' needs. And finally, and we take really good pride in this, that Azure really helps you build AI apps responsibly. And we provide a whole set of tools, services, and guidelines to help you build AI responsibly into your business critical applications. Microsoft has been identified as a leader in the Cloud AI Developer Services Magic Quadrant and is the leader when it comes to completeness of vision. The innovation that you're building or your AI-based innovation becomes rapidly scalable with Azure's industry-leading global footprint of infrastructure services. Azure is now available in more than 60 regions worldwide with more than 300 data centers, 275,000 miles of fiber, and more than 190 points of presence throughout the globe. This robust global footprint helps you deliver your AI apps with low latency and high reliability, no matter where your customers are located throughout the globe. One such customer that's rapidly innovating with generative AI is Crowdbotics. Let's hear from Anand Kulkarni, who's the CEO of Crowdbotics, on how they are leveraging generative AI to rapidly improve the developer experience and how they are leveraging and building their application on Azure. Anand?
Hi, I'm Anand Kulkarni, CEO and founder at Crowdbotics. I'm excited to be sharing one of my favorite topics with you today, how to achieve enterprise ROI with artificial intelligence. We'll be talking about how we have done supercharged development using AI, using Crowdbotics, and how you can achieve AI superchargement on your own development with Crowdbotics on Azure. So a little bit about Crowdbotics to get us started. We are a 7-year-old Silicon Valley-based AI platform, spin out of UC Berkeley, founded way back in December 2016. We got 110 people here, full-time and growing, and over 25,000 application repos connected to Crowdbotics today and being processed. We're trusted by a number of large enterprise organizations, and we've gotten over 88 million in funding from top investors. We're also a Microsoft partner and excited to work directly and deeply with Microsoft up and down the stack. So what is Crowdbotics? We're an AI-powered software development platform that automates big parts of the software development lifecycle for both the business side of the house and engineering and developer teams. The way we do that is by building AI models that can read and write code. So as we all know, most of the software development lifecycle excitement about where AI can supercharge our processes is focused on the IDE, on great tools like GitHub Copilot, which really let us think about how we can assist developers in building code faster. That's obviously super important and a tool chain that we love, one that we integrate deeply with ourselves. But we are also aware, like many of us are, that time spent in the IDE writing code is really only 10% of the problem that organizations face when they're trying to build software. 90% is focused on everything that comes before we're actually in the code. Time that we spend figuring out how to write or create requirements that help us understand what we are going to build, and time that we are spending figuring out the technical approaches that we take, using AI selection of modules or architectures. These are the places where 𝗦𝗏𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 we use generative AI to help teams plan requirements, generate and write clear requirements, translate those requirements directly into architectures and technical strategies, and then pass both of those directly into tools like GitHub or tools like VS Code to actually generate the code and implement software. So this is an integrated practice that we recommend and support called CodeOps, which allows you to unify generative AI into your planning cycles, into your architecture cycles, and into your actual development activities. Of course, we've been excited to partner with Microsoft for the last year. 𝗦𝗲𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 how that stack works and some of the different pieces today. But there's been deep collaboration between the two organizations for a long time. We've published joint research together. We have several active integrations. We're putting out material, several conferences this year. Of course, we're an ISV partner and transactable directly in the Azure Marketplace. And we are closely integrated with GitHub and with GitHub Copilot as a way to supercharge the software development lifecycle. So let's talk a bit about the technology stack and the platform itself. So 𝗦𝗫𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 These are all systems that use generative AI to connect the business side of the organization with the development side of the organization. We think about three big flows. The first one is a greenfield creation flow, which we think about as idea to spec, idea to specification. How do you generate application requirements using a synthesis of various files, structures, inputs, constraints, and requirements from inside the organization? In other words, we can turn open-ended concepts for new application initiatives directly into a detailed set of product requirements, user stories, sprints, using comparisons against what applications have been built in the past inside that organization or elsewhere in the world. We can go spec to code, which is taking requirements that exist out in our systems or inside the 𝗦𝗲𝗸𝗀 platform and translating those directly into components of code, writing that code directly, generating starter code for developers and teams to review. And then we can go code to spec, which is the reverse process and probably the most common process that we see inside 𝗦𝗲𝗸𝗀, which is taking some existing code base that exists, some existing application repo that exists somewhere, whether there is documentation or information about it or not, and turning that directly into a stack of requirements. So reverse engineering requirements out from existing code bases as a way to use AI agents to enhance that code base, as a way to modernize or maintain that code base, or as a way to just understand and document that code base. So three big workflows that we support. Idea to spec, where we can turn directly a short description of an application taken from non-technical users and expand that out into the necessary user stories, requirements, acceptance criteria, and implementation strategies. Here is the system you can see live. We'll take a simple requirement, just a paragraph that we might pull in from a stakeholder with a couple lines and flip this out into a set of features, functions, user stories, sprints, and application plans. This is often useful when we are thinking about ways to plan how we might approach a technical problem or figure out ways to strategize that organization. And you can see that it achieves generally pretty fast speed ups for teams when they're figuring out how they can initiate new greenfield applications, both by eliminating duplicate work and by reducing the back and forth that happens between our product teams and our developer teams when we are building software. This is not quite real time, but it's pretty close. It generally takes about 10 seconds or so to generate out full build plans, which is pretty fast. It's about 0.1% of the time that it might take to do equivalent work from a human. Of course, The second part of that is turning those requirements directly into relevant Azure services and components. So one of the key problems that's being faced by most teams when they understand how to write business requirements is trying to determine the trade-offs that exist between different approaches you might take that are technical when you are approaching a given problem. In many cases, our organizations or our customers' organizations have requirements about which particular solutions their IT teams like to use. So, for example, if you are a Microsoft Azure customer at scale, your IT team may want you to use previously authorized Azure services. 𝗦𝗲𝗶𝗀𝗀𝗻𝗀 uses generative AI to match the relevant Azure services that your team has authorized or your team has access to up against specific requirements that exist by looking at the relationship between requirements and potential solutions, which allows us to accurately recommend the specific approach that you can take and then write starter code that supports that specific strategy. That ends up saving considerable time when you're trying to figure out what approach you take when you are building software that meets a given requirement and lets you navigate the trade-off and the tension between time and pre-built solutions that sometimes exist when we're planning out technical architectures. And the other side that we often think about from a business standpoint is figuring out the cost structure that supports that underlying model. And of course, 𝗦𝗏𝗀𝗀𝗀𝗀 uses artificial intelligence to determine the forecast cost for the various services just from the natural language requirements, which is a powerful way to understand the ultimate consumption or usage that's going to be obtained when you're thinking about the total cost when building an application. So again, turning natural language directly into forecast costs. You can take this all the way down to a pull request by generating out specific code. You can also turn that directly into a underlying recommendation of how you can implement this application step by step. So here's an example for how we end up creating the starter code for a given application. And again, this is coming straight from the business requirement. Finally, the most common use case is the brownfield flow for creation of software, code to spec, where you take existing application repos, typically in GitHub, but sometimes in mainframe or other non-cloud solutions, and reverse engineering those directly back into product requirement documents, documentation, and specific recommendations on how to modernize. That approach and that pipeline ends up allowing teams to move very quickly when understanding how they can modernize or extend an existing code base, often a place where teams end up getting stuck when they're trying to understand the cost or difficulty of building software. Under the hood, this system pulls direct integration information out from GitHub, extracts it out into a temporary environment inside Azure, generates the relevant product requirement document, adds in relevant code context, and then under the hood constructs a graphical representation, a code graph of the underlying application, understanding relationship between different parts of the application and turning those into natural language descriptions that can be read and understood by a non-technical user, as well as managed by a development team or a product team to try and extend the application over its lifetime. As before, we can make use of the same infrastructure that was created to help recommend relevant modernization strategies or pick out relevant services that can be used to upgrade and extend individual applications. This is a powerful way to think about managing existing code bases in the AI era. So now let's look at the stack itself. Obviously, everything we are doing here is powered by Azure, but it's powered by Azure in several different ways. And it's often interesting to take a look at how we've structured this. Of course, under the hood, we're running on AKS, Azure Kubernetes Service. The database itself is Postgres, Azure DB, Azure Cache for Redis. We handle key management and secret management using Azure Key Vaults. Of course, data is stored inside blob storage where relevant. And the core of the machinery that powers most of the generative AI is Azure OpenAI 4.0 with fine-tune use heavily from datasets that we've collected and make use of. This combination allows us to move considerably faster when building and planning applications. And most of the machinery and the magic that you're seeing here is powered by a structure that makes relevant calls within Azure OpenAI and makes strong use of many of the solutions indicated as ways to accelerate the process of building and planning even large software systems. When customers use 𝗦𝗏𝗀𝗀𝗀𝗀𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏𝗏 most cases, customers are publishing directly into their own Azure tenants or into a 𝗦𝗲𝗸𝗀𝗀𝗀𝗀 controlled Azure tenant. In these cases, the standard applications that customers tend to modernize into become Azure Web Apps, again, using a similar structure. Azure DB for Postgres, Azure Cache for Redis, and of course, Azure Key Vault for managing secrets. Additionally, if there are several Azure services that have been planned and procured, those can be provisioned directly and added into the 𝗦𝗲𝗀𝗀𝗀𝗀 application using the workflow that we've seen before. This is a cool approach for how you can think about planning and launching new applications, either moving them into Azure if they exist somewhere else in the world, either in another cloud or as an offline solution, or for launching new applications inside Azure in a way that is much faster than how most teams are able to operate when doing this by hand. So in summary, 𝗦𝗲𝗀𝗀𝗀𝗀 is an exciting way to generate applications using AI inside Azure. 𝗦𝗲𝗀𝗀𝗀𝗀 itself is an Azure application, one that you can obtain and use directly inside the Azure ecosystem. We often use Azure's OpenAI to start the process of generation of code into specifications for legacy applications or modernization and migration initiatives. We generate requirements within Azure itself. We help use Azure's own catalog of services to design and architect applications that run inside Azure. And then, of course, we hand off to developer teams. Once those requirements and starter code is generated, we can pass those directly into Copilot and VS Code to develop the remaining code, or into tools like GitHub Copilot to generate code and to allow application code to reside in the place that end customers control. Finally, the end system gets deployed directly into Azure. So, in summary, we're excited to see the ways that customers can build Azure applications on 𝗦𝗲𝗀𝗀𝗀𝗀. We're also proud to be a partner of Microsoft and a good solution that most teams can use to accelerate their process of building inside Azure.
Thank you, Anand. That was very insightful. Now let's hear from Ravi and get a deep dive on how you can build your generative AI applications on Azure.
Thank you, Neelay. I'm excited to talk to you all about Microsoft's strategy and how it can help you build custom AI applications. Every other day, I meet companies who are born in the cloud, and each one of them are pushing boundaries in every way possible. My name is Ravi Sudhakar Kambhampati. I lead AI and machine learning business strategy worldwide for Microsoft. I focus specifically on cloud-native companies. Microsoft is a solutions and a platform company. We're focusing on specific design pattern which covers majority of the use cases out there. It is all about natural UI, context-aware, hyper-personalized design. Let me elaborate the design pattern. Let's say I speak to my phone and ask, what is the status of purchase order 12345? What if the response was, hey Ravi, the purchase order is pending with Neelay. Neelay normally closes the purchase order within a week, but this time it has taken more than 2 weeks. Don't worry, the PO is now taken up by Neelay's colleague and it is expected to be closed today. By the way, Neelay has been on sick leave for the last 2 weeks. Would you want me to call Neelay and find out what's going on? Look at this query and the response. It was supposed to be a transactional query. It is now very different. There are 3 things which happen here. The bot knows who Ravi is, his role as a vice president of sales operations, what is the level of access he has. It also has the context and the knowledge. And then the bot goes in and verifies the purchase order from an ERP system. And then goes into a KPI database or a data warehouse where it finds out what Neelay's KPIs have been. It goes in and finds out who has the purchase order now. Then it goes to the HR system and finds out Neelay has been on a sick leave. And the last part is generative portion of the entire solution. It just made a transactional query into a very natural one. This is where we expect a lot more development. And this development is coming across 3 different areas. The applications are expected to be multimodal. You must have seen, I spoke to a phone. It should take up text, audio, and video. The applications are using multiple models, which means that some tasks it might be useful to use a small language model, and for other tasks it might be useful to use a large language model. We are incrementally seeing more than two models being used across various different applications. And the third one is about agentic, where multiple assistants are going to come together to provide a holistic response. And Microsoft is actually spending a lot of energy and resources to make all of these three portions of design patterns one, secure, second, safe. The models are not jailbroken. The modality is safe both for input, output perspective, and the components are ethical, responsible, and following the safety guidelines put forth for the application or the organization. Expanding that further, Azure provides numerous components, resources, tools for cloud native companies to build secure applications across the stack. The stack includes a rock solid AI infrastructure where most of this intelligence is deployed with a best in class networking, memory usage. We have the best in class data services, which spans from database in a VM all the way to database as services, which allows our developers to build applications with what they know and what they like. And then we have the right application services, which provides them frameworks and tools to build agentic AI and multimodal experiences. And lastly, we have our AI platform, which allows you to build AI services. In some cases, you might want to just pick up a model and start with it. In some other cases, you might want to pick up an API and so on. And that's where Azure AI platform covers it all. You're now able to swap models through unified API, optimize it for your own needs. There are Azure OpenAI models, and then there are innovative models available as a service from our third-party vendors. Then you have services which allow you to build unique and differentiated experiences using our data services. Next to that, you have solutions which allow you to build safer solutions with prompt shields, custom category filters, and help you combat the latest threats in the market out there. And lastly, we have the operational framework, which allows you to collaborate with developers, data scientists, and data engineers. None of these concepts are stagnant. They call us to pivot and adapt on a regular basis. Let's dive in deeper in how we are thinking about when it comes to AI application being built. It largely encompasses four key components, which allow developers to build unique experiences at scale. Uniqueness comes across from customizing the most innovative models in the world and grounding them with your own data. Scale comes from having confidence in the safety system and the security system which supports all of this. And then you have to be equipped to manage the changes which come along with AI. The first component is about making sure that developers are able to innovate with the best models available. We understand that one model doesn't fit all. It depends on the use cases, task at hand, and sometimes the performance goals and the budget of the organization, which is why flexibility is really important. We all know there is no shortage of model innovation. And we realize it's not about providing thousands of models on Azure. It's also about making sure that you're able to make confident choice while picking up these models. You're able to compare the models, you're able to predict the computing costs, finally be able to pick up the right model for the use case and the task at hand and operationalize them in your applications. The second block is about differentiating yourself with data. A good Gen AI application is great when it is grounded with the right data, with the right integration. We often see customers challenged with complexity of data sources. There are always multiple dimensions of data. Some data structures are structured, some are unstructured. Some of them are legacy analytics, and new data is being generated every second of the day, causing difficulty in indexing them, integrating them, and re-ranking them for better insights. That is where our toolchain plays a central role in making sure that we chunk the applications right, we vectorize the apps for quick response, and we are able to index them for accuracy. And then finally re-rank them for deeper meaning. You can all work with any dataset. The dataset can be on Azure, the dataset can be on any other cloud or even on premises. The next area is safeguarding the application overall. As we are seeing the increase in adoption, bad actors are also using similar tools and finding new ways to manipulate the systems. The attacks are emerging. The outputs generated by Gen AI is also raising concerns about liabilities related to potential IP infringement. At Microsoft, responsible AI is just not a theory. It's also in practice. And we're learning every day. With responsible AI tooling, our customers are actually building Gen AI applications to market with confidence. We help not only scanning videos, we scan images, text to identify and block any harmful content. We can be even more surgical in setting up the filters, such as stopping bullying in addition to stopping violence, hate, self harm, and so on. And finally, with respect to risk infringement, we provide tools to identify protected material detection. And the last tenet of AI platform is about making developers' life easy while they are operationalizing a production application for their organization. With the right tools in hand, these teams can come together and manage the full life cycle of Gen AI experiences. It's developers who, after all, make the magic happen. When they have the right tools, they can stay in their preferred flow and they deliver the best work. Azure AI Studio is our developer hub for Gen AI. It makes integration seamless for familiar open source tools, frameworks such as Semantic Kernel, LangChain, and AutoGen. The customization, monitoring, evaluation are all available to our developers. It's also intuitive for developers for all skill levels. Finally, as you're developing world-class applications, it's the end-to-end application ecosystem which enhances the overall solution journey. You can easily integrate it with incoming events as you leverage APIs existing outside of your solution. To enrich your solution, you want to work with any dataset located anywhere. You can process it, you can build it, you can expand it. You can bring the analytics to fuel richer experiences and insights and inferences on Azure. And finally, you can deploy them on Azure Kubernetes services, app services, or our serverless landscape, which empowers you to build applications for any use case using any integration. Again, AI platform is rich with services and frameworks. It covers it all. With that, I would like to hand it back to Neelay back to close this Ignite session.
Thank you, Ravi. So, folks, I know this was a lot of information, and we understand that the best way to get started is to get hands-on with all these technologies. And based on your preferences, we have put together different ways in which you can start getting hands-on. If you need one-on-one assistance, we have set up the Microsoft AI Co-Innovation Labs, where you can work side by side with our Microsoft technology experts on the architectures as well as wireframes for your AI apps. If you really want to get started on your own and start kicking the tires, we've put together a collection of curated templates called the AI App Template Gallery, which include templates on a variety of use cases, as well as they're built on a variety of models, frameworks, programming languages, as well as services. These templates are also built for security and reliability, and many of these templates deploy in as little as 5 minutes. Finally, if you are a startup that's just getting started, I would highly recommend signing up on Microsoft for Startups Founders Hub, where you can get credits, expert guidance, as well as access to your whole network of peer startup founders and professionals. Thanks for listening.